Hi, I'm Miss Boom. Today we're going to look at quadratic models. Example 1. Yunuli wishes to fence off a strawberry garden in her backyard. She has 16 meters of fence which she will use for 3 sides of the garden, with an existing wall as a 4th side. Calculate the maximum area she can enclose. So let's draw a diagram first. So she has 3 sides to work on and 1 side is a wall, and these 3 sides have to add up to 16. So if I name one side as x, then the other side will be whatever left over from 16 meters. So each of these sides would be 16 minus x divided by 2. And we can simplify that. 16 over 2 is just 8 minus x over 2. Now the area is what we're looking for, and it says it's asking for the maximum area. So let's calculate the area. The area is length times width, so let's multiply these two together. And now we have 8 times x is 8x, and then x times minus x over 2 is minus x squared over 2. I've just rearranged it so that the highest power of x is always to the left. Now we can take out a minus half. So now we're left with x squared minus 16x, because minus and minus gives us a plus. So now completing the square, that's 16 over 2 is the 8 there. Now don't forget the bracket so that we can expand the minus half to the minus 64. Minus half times minus 64 is positive 32. Now we have the equation in turning point form with the turning point as 8, 32. So the maximum area is the y value, which is 32. So we can write it, our answer, the maximum area is 32 meters squared when x is 8. Oh, bless me. Example 2. Angelina throws the ball and it leaves her hand at a height of 1 meter above the ground, and Gab catches it 8 meters away at a height of 1 meter. It is known that after the ball has gone 2 meters, it is 13 meters above the ground. If it's getting confusing, I would go through and label which one do I think it's an x and which one I think it's a y. So height of 1 meter, that sounds like a y. And then Gab catches it 8 meters away, so that's x. Height of 1 again, so y. It is known that after the ball has gone 2 meters, it is 13 meters high. So x is 2 meters and y is 13 meters. Now the initial x value would be 0. So I'll write those things down. Part A, the path of the ball forms a parabola. Determine this equation. So from the data, we can write them coordinates down. So 0, 1, as we said, and then we have 8, 1, and we have 2, 13. Next, we can write the equation, and we can write it as the standard form or the y-intercept form because we have 3 points. Recall which form to use from the previous video. So now we substitute. We substitute 0, 1 first because it has a 0. We can figure out what c is. Plugging in all the x's as 0 and y is 1. C is clearly 1. Then we can rearrange the equation to write it as c as 1. And then we're going to use this equation to substitute the other values. So when we have 8, 1, sub it in this equation, we will get y is 1, 8 squared is 64, and then 8b plus 1, and cancel out the 1s on both sides. We have 0 equals 64 plus 8, and then substitute the other value in to, again, that equation there. We have 13 equals 2 squared is 4a plus 2b plus 1. Get rid of the 1 on both sides. We have 12 equals 4a plus 2b. Now we have these two equations. Let's do this second equation minus 4 of these. So 8b minus 4 times 2b would cancel out. So now we have that minus 4 of those is 0 minus 4 times 12 is minus 48. And then 64 minus 4 times 4 gives us 48a. So a is equal to minus 1. And then we sub that into the easier equation. I can do this equation or that equation, but sub it into this equation. So 64 times minus 1 is minus 64. And then bringing the dividing by 8 gives us b equals 8. So now we have the equation as y equals minus x squared plus 8x plus 1. Thanks for watching. I'll see you next time. Bye.